All right, so this is problem 29 in the set of problems to review for the final exam. And we're going to wind up determining this is a linear system when we examine the problem a little more closely. I will point out that we're given some answer choices down here. And if you read the problem carefully enough, you're going to conclude that one thing you could do is you could just trial and error. In other words, you could say, well, if I get 5 of these times 250, for example, plus 4 of these times 1, do I get the 1550? Yes or no? And then once you've decided that, then take those same values, replace them in here and here, and see if you get the different amount, right? So you could do trial and error, but let's don't do that. Let's be a little more competent in what we're going to do to solve this thing. So what are we looking for here? Well, we're looking for the price for a hot dog, and we're looking for the price for a bag of chips. So we're looking for the price for a hot dog and the price for a bag of chips. Let's call this X and this Y, just to stay with our normal designation of variables. And let's build some equations. So we're going to have 5 plus 4 is equal to $15.50. I'm leaving the dollar signs off here. So again, if I knew this price and I knew this price, multiply them, add them, I'd get $15.50. And then, but remember, whatever I use here and here has also got to solve, it's got to satisfy this one. So I'd have to say that 2x plus 5 of these is now equal to $8.75. So you might find a result that satisfied this one, but that same values will not satisfy this one. So we need the same value of x and the same value of y that will satisfy both of these equations. And so let's do the method where we eliminate a variable. Now, how does this make any sense, what we're about to do? Well, just to recall that this side equals that, this side equals that. Whatever I do over here on this side on the left, I'll do the same thing over here. Even though it results in different numbers, it will be an equivalent change, because as we've said before, when we are using equations, we can treat them like a balancing act. What I do over here, I got to do on this side. If I add here, I must add here, for example. Now, so I'm going to somewhat arbitrarily, I'm going to multiply this one by -2, the entire equation, and this one by 5. And you'll see why in just a minute. So let's go ahead and do that. So I'm going to get minus 10x minus 8y. And this is minus 2 times 1550, so that's going to be minus 31. This is now plus 10x plus 25y is equal to, let's just do this in the calculator here. Sometimes it's better to do this arithmetic in the calculator, because if you make a mistake, you'll, whoops, turn it on first. So we get 4375. We get 4375. Now what are we going to do? Well, this side equals that side. This side equals that side. So now I'm going to combine them. So I'm going to be adding these equals to these equals to these equals. So it looks like we're doing something that's not correct, but if you follow the logic where I have this quantity equal to that, I'm just going to add an equal amount to here, and on this side, since the quantity that I added here is equal to that, I'm going to add it to that side. And the reason why we're doing this is a minus 10 plus 10, I eliminate my x's. Minus 8 plus 25 is going to give me this. And then 4375 minus what, the 31 is 1275. Is 1275. Now what do we do? Well, now we're going to divide both sides by 17. And that's going to give me that y is equal to 75 cents. So we've concluded at this point that a bag of chips is 75 cents. Well, what is a hot dog? Well, let's take arbitrarily now the second equation. I could have taken the first one, but I'm just going to take the second one. And I'm going to say, well, let's solve for x. So I'm going to say the original equation now. I'm going to say 2 times x plus 5 times 0.75 equals to the 875, and 2x plus 5 times 0.75 is 3.75. Subtract the 375 from both sides, and I get 5. Divide by 2, and I get 250. And so now I think that a bag of chips costs 75 cents. My chips, my hot dog, I think these are the prices. Now let's confirm that. Let's take this equation and replace x and y with these values, and then we'll do the same thing and see if it satisfies the whole system. You ready? So 2 times 250 plus 5 times 0.75. Does that equal to the original 8.75? So this is now what, 5, and we already knew that was 3.75. So yeah, you add those two together, you're going to get 875, right? So this one checked. What about the first one? Let's see if the first one checks. So I'm going to say 5 times 2.250 plus 4 times 0.75. Does that equal to the 1550 that I had up there a minute ago? All right, so what's 5 times 2.5? 5 times 2.5 is 1250. So that's 1250. And 4 times 0.75 is $3. And lo and behold, that is 1550. Okay, so it checked. All right, so that's cool. So the answer is 75 cents for a bag of chips, $10.50 for a hot dog. All right, which answer is that? 75 cents. Okay, so the answer to this one is A. The answer to this one is A. Now, you might have thought to yourself, there's probably more than another way to work this problem, and there is. And let's just think of another way that we could work it if we wanted to. And I want to think about a graphical approach to work this problem. So now bear with me. I'm going to take the original equations and I'm going to slightly rewrite them. I'm going to rewrite them. So I'm going to take this equation, the 5x plus 4y, and I'm trying to move this around where you see the work initially. I'm going to rewrite this equation such that 4y is equal to 15.5 minus 5x, and then I'm going to rewrite this equation such that 5y is equal to 8.75 minus 2x. Now you say, what are you going to do now? I'm now going to solve these for y. I'm going to have, this is now going to be 15.50 divided by 4 minus 5 divided by 4x. This one's going to be y is equal to 8.75 divided by 5 minus 2 divided by 5x. Just rewrite these, exchange, just a little bit. Minus 5/4 x plus, I'm not going to do any of the division. I'm just going to leave them the way they are. Okay. So what have I got now? Well, now I got myself two linear equations, don't I? Y is equal to mx plus b. So this is y is equal to mx plus b. I can put these in my graphing calculator, and what should I find? When I put them in my graphing calculator, they both have a negative slope, so they're going to be looking something like this, kind of something like this. Who knows what they're going to look like exactly? But I'm going to find an intersection point, and if we've done this right, the intersection point should be the x's and the y's that we found so far. So the intersection point should be 2.5 here and 0.75 here. So that point there should be the 2.5, 0.75 point. And we'll probably have to play around with that window a little bit and the table, but let's put them in the calculator and see what we can get here. You ready? So the first one was y is equal to, I'm trying to position the calculator and the work so we can see it all at the same time. That might be a little hard, but we'll give it a shot here. So I'm going to put in the first one, which is going to be this is hard, the negative 5/4 x down here. The negative 5/4 x. I'm going to put this one in, and then I'll put this one in. So I'm going to put in negative 5/4 x plus 15.5 divided by 4, right? So here we go. I'm going to have negative, I probably don't put this in parentheses, 5 divided by 4x plus 5.5 divided by 4. Did that work? So negative 5/4 x plus 15.50 divided by 4. I'm just making sure I got the right thing in the calculator. Now the next one's going to then be negative 2/5 x, negative in parentheses 2 divided by 5 parentheses x. There's negative 2/5 x plus 8.75 divided by 5 plus 8.75 divided by 5. And here we go. What about our window? Maybe before I grab it, let's see, zoom standard. Let's start off with our standard viewing window here. Okay. Ooh, it's going to graph it. There's one of them. Boom. Boom. Hey, they kind of look like we thought they were going to look. Ooh, it's going to be hard to read these values. So here's what we're going to do now. We're going to hit our table. I was going to change this table. I'm going to hit second table set. And why am I going to do this? Let's start the table at 0, right? Because I'm not interested in any negative prices or negative hot dogs, right? So let's make our negative prices or negative quantities. So I'm going to start my table at 0. And I'm going to change the table by 0.5. Why? Because I got units of money that are in half dollars and 50-cent pieces, right? So hit enter, second table. Now what I'm looking for is what am I looking for? I'm looking for the value of x where I have the same value of y. Well, there it is, son of a gun. When x is $2.50, the chips are 75 cents, and the hot dogs are $2.50. So this is the intersection point. So this point of intersection is the same as the value that we calculated. Now let's change the window just a little bit so we can see this a little better. So I'm gonna go from 0. I'm kind of arbitrarily doing this now. I don't want any negative values, do I? On either side here. And let's make that a 5. This is going to tighten up the window so the graph will be a little clearer. Hey, there we go. There's the first one. And here comes the next one. Boom, boom, boom. Ooh, it's close right here. So, and what did we say? This is the hot dog price. This is the chip price. So here is an intersection point of 2.75 on 2.5 on X and 0.75. Now, second, calculate intersection. There it is. There's the intersection of the graph. Okay, so that's enough of this. And again, what did we conclude? We concluded that the answer to number 29 after all of that conversation is A. The answer to 29 is A. And so I'll just leave this here. And here's the graph. Here are the equations that we put in to make this work. Okay. Enough of that.